Let's face it, lithium-ion batteries are everywhere. They power our phones, our laptops, our cars, pretty much our entire modern world. But as we demand more and more from them, we're starting to hit a wall. So the really big question is, what comes next?
So here's what we're going to dive into. First, we'll look at why lithium-ion is the undisputed king right now. Then we'll explore the cracks starting to show in its crown. After that, we'll see how scientists are trying to evolve the champ and also look at some totally new contenders entering the ring. Finally, we'll piece it all together to see what our energy future might look like.
Before we can talk about the future, we really need to appreciate the present. And right now, we're living in the lithium-ion empire. This isn't just another piece of tech, it's a foundational pillar of the global economy.
And the scale is, well, it's just mind-boggling. We're talking about a market that's projected to hit nearly $500 billion within the next decade. That's a growth rate of over 17% every single year. Things are moving incredibly fast.
So, what's fueling this explosion? A huge piece of the puzzle is the electric vehicle revolution. I mean, just look at this chart. The demand for EV batteries has gone completely vertical, especially in places like China and Europe. This one application alone is reshaping our entire energy landscape. So how did lithium-ion take over the world? Well, it was the perfect storm. It packs a ton of power into a really small, light package. It can charge up fast, and it lasts for hundreds, sometimes thousands of cycles. And the real kicker? The price has absolutely plummeted, down more than 80% just since 2013. That's what made everything from EVs to grid storage actually affordable.
But, it's tough being the king. For all its success, the crown is getting heavy. The same incredible growth that put lithium-ion on top is now exposing some of its biggest weaknesses.
And the first major headache is resources. The demand for critical materials, we're talking cobalt, lithium, nickel, it's just soaring. The problem is, this stuff is not only hard to find, but it's often concentrated in just a few spots on the globe, which you can imagine creates some serious risks for supply chains.
Then there's safety. We are constantly pushing to pack more energy into these batteries and to charge them faster and faster. But when something goes wrong, you can get what's called thermal runaway. It's basically a chain reaction where the battery heats up uncontrollably, and that can lead to fires or even explosions. It's a risk that gets a lot scarier when you scale things up to the size of a car or a shipping container.
So to sum it up, while lithium-ion is an amazing technology, it's hitting a perfect storm of challenges. The cost of its key ingredients is a problem, the supply chains are fragile, every battery eventually just wears out, and safety is always a concern. And that is why the race is on to figure out what's next.
But here's the thing. What's next doesn't necessarily mean throwing out the old playbook. The first strategy is to take the champion we already have and evolve it into something much, much better.
And this isn't just a few scientists tinkering in a lab. You've got these huge efforts, like the Battery 500 Consortium. They've brought together the best of the best, national labs, universities, industry players, all with one goal: create a new generation of lithium batteries that can store way more energy and last for at least 1,000 cycles. And they're making some seriously impressive progress. Look at this. Back in 2017, their high-energy prototype was toast after about 50 charges. Fast forward to 2021, and a similar battery is lasting for almost 600 cycles. It turns out a huge part of the solution was a new electrolyte that did a much better job protecting the anode from degrading. We're talking a 10-fold improvement in just 4 years. That's incredible. Okay, so improving lithium-ion is one critical path forward, but at the same time, researchers are exploring some wild, completely new ideas for storing energy, technologies that are based on a totally different blueprint. For instance, check out the redox-flow battery. Now, this is a totally different beast. Instead of everything being packed inside one little can, it stores energy in giant external tanks of liquid. This means you can make it store more energy just by making the tanks bigger without changing how much power it can put out. That makes the whole design incredibly flexible.
This kind of scalability makes flow batteries the perfect marathon runner for the power grid. Think about it. You can spend all day charging up these massive tanks when the sun is out, and then you can discharge that power for hours and hours all through the night. They are a huge piece of the renewable energy puzzle. And now, people are working on new, cheaper, organic electrolytes to make them even better.
All right, so flow batteries are the marathon runners, and supercapacitors are the Olympic sprinters. Technically, they're not even batteries. They store energy physically in an electric field, kind of like static electricity. This lets them dump a massive amount of power in an instant,
and then recharge just as fast. The craziest part? They can do this millions of times with almost zero wear and tear. They're basically immortal.
And new materials are making these sprinters more powerful than ever. Two of the big names right now are graphene, which you've probably heard of, and a newer class of super-thin materials called MXenes. As you can see here, MXenes have some key advantages. They can store more charge and move it around faster. These kinds of breakthroughs are starting to blur the lines between batteries and capacitors, giving us the best of both worlds. Okay, so we've got the evolved champion, lithium-ion, we've got the marathon runner, the flow battery, and we've got the sprinter, the supercapacitor. The big takeaway here is that the future isn't about finding one single technology to replace all the others. It's about building an entire ecosystem of solutions.
And you can already see how it all fits together. We'll still need advanced lithium-ion and eventually solid-state batteries for our cars and phones, places where being small and light is everything. But at the grid level, giant redox-flow batteries will become the workhorses, soaking up solar and wind power. And supercapacitors, they'll be used wherever you need a massive, instant burst of power, like for regenerative braking, or giving an EV that extra punch of acceleration.
And this really gets to the heart of it. The future of energy storage isn't a kingdom with one ruler. It's more like a vibrant, diverse ecosystem, with different technologies perfectly suited for different jobs, all working together to make the whole system more powerful and resilient.
And why should we care about all this? Because honestly, getting energy storage right is the key to solving some of the biggest challenges we face. It's how we actually decarbonize our economy, it's how we make our power grid stable enough to run on 100% renewables, and it's how we spark a whole new wave of innovation and economic growth all around the world.
So it's clear our energy future requires a whole toolbox of solutions, not just one silver bullet. As all these amazing innovations start moving from the lab into the real world, I'm curious, which one will you be watching?